Hi students, today we are going to discuss another technique for the synthesis of nanostructures. It is called the Sol gel technique and it is one of the most commonly used techniques for synthesizing nanostructures, which includes nanofilms, nanopowders, etc. Now, what is the Sol gel technique? It is a wet chemical based self assembly process for nanomaterial formation. So the name comes because it involves the formation of initially a sol and then a gel. Now what is a sol? Now sol is a colloidal suspension formed from the precursors. Precursors means the reactants that you are using. A colloidal suspension is first formed from the uh, precursors and it's called the sol. After that, the gelation of the sol takes place. Gelation means some kind of network is formed in this continuous liquid phase. That is, by means of some kind of cross linking, a network is formed, and that phase is called the gel. Okay. Initially, a colloidal suspension is formed called the sol, and later the sol is converted into uh, a solid or a semi solid continuous network, and that is called the gel. The gel is usually it has a sticky appearance. Now, the precursors used here generally consist of metal ions and ligands, ligands which are elements surrounded by reactive species. Metal oxides like aluminates, titanates, cuprates, and alkoxysilanes are the most commonly used since they are the most commonly used precursors because they are soluble in water. A few alkoxides which are immiscible in water or insoluble in water, for them solvents like alcohols are used. Now we are going to discuss the four important steps in the formation of the sol gel in the sol gel synthesis technique. First is hydrolysis and alcoholysis, that is, you dissolve it in water or alcohol. Next, water and alcohol condensation and polymerization of monomers to form particles. Next stage is the growth of the particles. The fourth stage is agglomeration of the particles, followed by the formation of networks throughout the liquid, that is the formation of the gel. Okay, so we have written down the steps from the formation of the sol to the uh, gel. Now, the structural, electrical, and optical properties of the sol gel derived can be varied by changing the pH of the sol, the reaction temperature, reagent concentration, reaction time, aging temperature, time of gel formation, etc. All these features can change the structural, electrical, and optical properties of the gel formed. Now the gel which is formed now you by those four steps. The four steps, first is hydrolysis and alcoholysis or alcoholysis, and then water and alcohol condensation and polymerization of monomers to form particles, the growth of these particles, agglomeration of these particles followed by the formation of the network. I told you a network is formed in this gel during the gelation process. So, the formation of network throughout the liquid. That by these four steps, at the end of the fourth step, the gel is formed. The structural, electrical, and optical properties of the gel can be changed by varying the pH, reaction temperature, reagent concentration, reaction time, aging temperature, time of gel formation, etc. Now, the gel which is formed is converted into the desired solid form, that is, into the desired nanostructure in several ways. So, that I have shown here as a branched chain, that is, the gel which is formed if you dry it slowly, if it undergoes a slow drying process, then it forms something called the zero gel, that is a solid phase, which undergoes calcination, which if calcined, it forms dense ceramic material. On the other hand, if the gel is dried rapidly, then it forms aerogel. Again, it's another solid phase. This same gel, if uh, we are using surfactants, it can be used to form small gelled spheres, which again on calcination can form nano powders. Or this gel can also be used to produce structures like nanorods using nanoporous matrix. That is, you take some material, uh, some porous material, and the gel is guided into the pores by methods like sonication and then dried. That is, you allow the gel to fill in the pores of the porous matrix by methods like sonication, and it is then dried. The porous matrix is then removed by some process like etching, and what we get will be these nanomaterials in the form of nanorods. If the pores have the shape of rods, then you will get nanorods. So the gel can be converted into different type of solids by following different processes. Either you can slow dry it and form dense ceramic solids, or you can rapidly dry it to form aerogels, or you can use surfactants and then calcine it to form nano powders, or you can use a nanoporous matrix to form nanorods. So the gel can be converted into a number of nano structures. This method can also be used for the synthesis of nanofilms, uh, thin films. I meant sol gel technique can be used. So, uh, for the formation of thin films on substrates, we use methods like dip coating, spin coating, spray pyrolysis, etc. Okay, the sol gel can be used to deposit thin films on substrates by means of processes like dip coating. Here, sol gel is used to deposit thin films on various substrates via dip coating, spin coating, spray pyrolysis, etc. So this is the sol gel technique, wherein we use, it is a wet chemical based self-assembly process. It involves the formation of first a colloidal suspension from the precursors, and that colloidal suspension is called the sol. After that, a solid network is formed in the liquid phase, and that is called the gel. This gel will have a quite sticky, it will have a sticky texture. This gel then can be converted into different types of nanostructures uh, depending on the method that we follow after the gel formation. Yeah, it can either be slow dried or dried rapidly, or it can be uh, mixed together with surfactants to form nanopowders, or it can be used together with uh, porous matrices to form specific shaped nanostructures like nanorods, etc. For the formation of thin films, you dip you do either dip coating or spray pyrolysis or spin coating, etc. of this gel material, and then you follow annealing processes like annealing to obtain the thin film. So this much about sol gel technique. I hope this session is clear to all of you. If you have any doubts, please do contact. Thank you.